Students, कुछ बात शुरू करेंगे about the digital transmission. We have discussed that our data that needs to be transmitted, it can be analog or digital. Similarly, the signals that we actually send, they can also be analog or digital. And students, the two different types of signals that we need to send, they can be digital transmission or they can be analog transmission. Digital transmission can be of two types. We can send the digital data in the form of digital to digital conversion. So we have digital data, we convert it into a digital signal and we transmit it over a transmission medium. Students, in the second case, we can have analog data that we convert to a digital signal and we send this digital signal over the transmission medium. Students, will start our discussion with the digital to digital conversion. So our data is digital and we need to convert it to a digital signal and we'll send this digital signal over the transmission medium. Students, digital to digital conversion, this process, it involves three different techniques, three distinct techniques. The first one is called line coding. Whenever we need to convert digital data into a digital signal, we need line coding. So it's always needed. So the second technique is block coding, and we'll discuss it in further detail, but for now, you should know that it may or may not be needed. Then we have scrambling. Once again, scrambling may or may not be needed. अब students, इससे पहले कि हम लोग line coding की details में जाएं, we'll talk about a couple of concepts that we'll be using throughout our discussion of the digital to digital conversion. Students, the first concept is of signal elements versus the data elements. Students, a data element is the smallest unit that can carry any meaningful piece of information. In other words, this is our bit. Students, a signal element is the shortest unit in terms of time of a digital signal. Students, we need to carry the data elements and we use the signal elements to carry these data elements. So, data elements are being carried and our signal elements are the carrier. Now, students, slide pe chalenge and we'll look into a couple of scenarios that actually allow you to distinguish between these two concepts. So, students, as you can see in the slide, we have got four different scenarios. Before we start discussing them, we will define a ratio, small r, and the small r is the number of data elements carried by each signal element. So this r is actually our number of data elements which is carried by each signal element. An important concept that we'll be using in further topics as well. So students, in the first scenario number A, you can see that we are sending one data element. We are sending one bit per one signal element. We have got one data element on the top and we have got one signal element that is carrying it. R, the ratio R is equal to 1. Now, in scenario number B, we have got one data element, once again on the top. But in this case, we are using two signal elements to carry one data element. We are using two signal elements to carry one bit. The value of R, as you can see, is 1 by 2. Scenario number 3. We have got two data elements and we have got one signal element. So the value is the ratio R, the value of R is 2 in this case. Students, last case, we have got 4 data elements and these 4 data elements are being carried by 3 signal elements. So the value of R, the ratio R is 4 by 3.